We're here to talk about Windows Azure, and specifically we're here to talk about building advanced applications on Windows Azure. I have no idea what that means. When we decided that we were going to have the talk, we said, you know what, we got to have something that goes beyond hello world. We can't just keep showing people, hey, look, you can put up a web page and then you can press some buttons, right? So we said we're going to do, when we were planning the session, we said we're going to do advanced stuff. So we're going to show whatever the cooler, advanced features are that people who have already been playing with the platform might find really useful and interesting, but they may not have gotten to yet. And one of the reasons you may not have gotten to these features yet is that we ship them on Friday. So, so this talk has sort of turned into the let's see how to develop with the new features talk. And I'm not covering everything that's new, but I'm trying to touch on some of the things that are really important, really fundamental to the way that we've been opening up the model in Windows Azure, and will help you build all sorts of really complex and interesting apps. I'm, of course, going to build a little toy because we don't have much time in the session to do anything. So it's not going to be a particularly fancy app, but it is going to be complex, and it is going to be fairly advanced. So what I'm hoping is that most of you have a basic kind of understanding of Windows Azure and have used it before, but let's check. So how many people think that, I know how to write a Windows Azure app, I've used the tools, okay, wow, that's the overwhelming majority. That's great, because then this talk is for you. This talk is for the person who's played with this stuff, has been waiting to see what's new, and wants to go beyond that. So who am I? I'm that guy whose face is on all the posters out there. My name is Steve Marks. I'm a technical strategist on the Windows Azure team, and the phrase technical strategist means about as much as the phrase advanced in my talk. Aside from being sort of the mascot on the posters, I do a lot of blogging and a lot of communicating with developers on the forums. I now own sort of our web presence for developers. I do a lot of talks, and so what I'm into is showing people cool stuff about our platform. And once I've shown them the cool stuff that they can do, finding out what they want to do with that, what they think is missing, what we need to go do next. So I'm very interested in your feedback. And after this, we're not going to have much time, if any, for Q&A at the end of this. But I'm going to go straight from here to that big giant room to stand in front of a giant picture of my face and hang out at the booth in the Windows Azure lounge in there. So if you guys have thoughts after this and want to come up and say, hey, you know what, the killer feature you guys are missing is X, I'd love to hear that. That's really useful stuff for me. OK, so let's dive right in. This is what you've all seen. This is really Hello World. This is what Hello World consists of really in the cloud these days. It's the asynchronous web and worker architecture. We've been talking about this for about a year since our first CTP came out of Windows Azure. Don't knock this pattern, despite the fact that I'm going to sort of skip past it because now we can do much more interesting and complex things. The fact that we can do more interesting and complex things doesn't mean we can do better things. This is actually a really great pattern for a lot of different applications. So keep the model of sort of a worker role sitting in the back doing work asynchronously, a web role kind of serving UI. Now you can do stuff that looks like this. You can do whatever you want. You can have as many roles as you want. You can have all sorts of arrows connecting them because anyone can talk to anybody else. You see in here I've labeled HTTP and XMPP just to make the point that you can listen on multiple ports. You can listen with different sorts of applications. You don't even need IIS if you don't want. You can run something else. Yesterday I did a talk where I showed Tomcat and Java code listening to port 80. This is just we've just sort of unveiled a lot of the underlying technology in Windows Azure that really lets you set up very complex kind of services. This is what we're going to build. So it's slightly more complicated than Hello World. So instead of sort of the web in the front, the worker in the back, we've got a couple different endpoints in the front. We're gonna have an SMTP server running in the cloud, listening to email. So that's just sort of a TCP port 25 thing. We do have a worker in the back. That worker does some work asynchronously, but it's also serving up some results because it's actually going to be a little search engine we're going to build. And so the web page has to go back there. So this will kind of show some of the ways that we're opening up this model. Let me show you. So one of my hobbies these days is coming up with domain names that aren't taken. And so I managed to get, everything I'm going to show you is running on the local development fabric in this session, so it's not actually running out on the internet. But I did get mindchive.com which is supposed to sort of be a archive plus mind sort of thing. You'll see it's sort of a place to store your notes, is the best I could come up with. Okay, so I've got an app here. I'm just going to press F5, and we'll just run it for now. And this app actually has very little of what we're going to end up building. Right now, this app has just a web front end, and it stores some data. We're going to add in, throughout the course of the session, the SMTP server. We're going to add a search backend, and we're just going to keep building this up as we go. So here we are running. So this is running local development fabric. It's actually talking to cloud storage, but that doesn't really matter. I could have been talking to the local development storage. I just happen to do it that way. So there's a search box, but actually that won't work yet because we haven't rigged that up. But here's the basic application. You put in a title, first title, and you put in a body like first body, and you say save it, archive it. Your chive has been saved. Maybe it should be pronounced chive if it means archive. Click here to view it. You view it. It's got some ugly GUID. I'm not sure if you can read that from the back, but there's some GUID in the URL. That's actually the name of a blob. It's the name of a table entity that we've stored in table storage in Windows Azure, and it shows me first title, first body. So here we go. I said we're not going to do Hello World, and then I built an ASP.NET MVC app that uses table storage. Okay, but this is the starting point. So what I want to make sure everybody is comfortable with here is what we've got, because we're gonna move beyond this, and it's important to be a little bit oriented. So I'm gonna just quickly pull up here my model file. Let me get all this stuff out of the way so that we can see. So if you use table storage, by the way, there's a storage client library that was part of what got shipped on Friday that is not sample code anymore. There used to be this sample storage client library. There's an official shipping version that's now part of the SDK. That's what I'm using here. So if you see something and you're like, that syntax looks a little unfamiliar, that's probably why, because I've already converted over to using that. So we have these things called chives, and they have titles and they have bodies. Okay, so nothing terribly complex. We also have something here, a chive reference, which we're going to see later. And this is basically me building my own secondary index. So this way I get to put a different partition key and row key, and then it just sort of points back to one of the chives. And then I have a context here. Okay, so this should be this sort of remedial for most of you, I think. So that's what we have. And then we have an ASP.NET MVC web page that's actually serving these things up. Going to quickly introduce the tool because we'll use it later. This is Azure Storage Explorer, and you may have seen this. It's on Codeplex. It was actually probably one of the first sort of storage tools for developers to appear after we announced our CTP of Windows Azure last year. And here you can see, let's see, I forgot to run Zoom it, so I can't zoom yet. But if I do that, then we can do a cool trick, right? So you can see here, there was that ugly GUID that showed up in the URL, and there's the body and the title that we put in. Okay, so that's the app as it stands for now. Pretty boring, I hope, because then it's going to be interesting, the things that we can add to it. So that's the basic idea. We're going to build it out. We're going to add an SMTP server. We're going to add a search server to it. So we're going to end up with this thing that has 3 roles. If you remember, we used to only be able to have 2. We can now have as many roles as we want, which is great. Actually, in the CTP, we cut you off after 5 different roles. But in the limit, you know, when you're paying for this stuff, it's going to matter what your credit card limit is, not some arbitrary thing that we've put there. So 3-role architecture. We're going to have the web UI, that's ASP.NET MVC. We basically saw that. I'm not changing anything in that for the rest of the session. Okay, that was it. We're going to have an SMTP server, which I've sort of stubbed out, but I haven't hooked up yet. So we're going to show how we hook that up, how we get the traffic from port 25, and then sort of the innards of it do the exact same thing as the website. Instead of typing in a subject and a body, I'll send an email with a subject and a body. And then we're going to add search, and we're going to use something called Lucene. And I don't know if anybody's familiar with Lucene. Probably a lot of you are, because it's very popular. Really, search API, I guess is the way to say it, is Lucene. And we're going to use the .NET variety of Lucene. The new features we're going to take advantage of. We're going to take advantage of the fact that we can have 3 different roles. We're going to take advantage of the fact that those roles can talk to each other in whatever way they want. And I'll show you how to do that. We're going to take advantage of the fact that we can listen to traffic that's not HTTP, which is important for our SMTP server. We're going to take advantage of the role instance lifecycle, which now gives you a chance to do things like initialization and graceful shutdown, and important for things like when you're building a search index. So when we get there, we'll see how we can use that. We can use different VM sizes. We've got a search index. It wants lots of RAM, so we're going to use a really big VM, and that's also new. And we're going to use local storage, and the thing that's new about the way we're going to use local storage is we're going to get to keep our local storage even after we do upgrades. So we don't have to lose the work that we've saved locally. And so we're going to take those sort of one at a time. General advice for modeling your application, because the world is getting more complex, the models are getting more complex. Draw boxes and arrows and answer a few questions, which is, which one of these different roles needs to receive internet traffic? So which one needs a load balancer and traffic routed to it? Which of them talk to which other ones? And which ones need IIS? So we now have this somewhat strange nomenclature of web roles and worker roles, where web roles used to be the guys who got the internet traffic. Well, worker roles can now too. And so the real difference is, in a web role, IIS is what receives the traffic and then invokes your code. In a worker role, you just listen on the port. You open up a socket and start listening. Okay? So it's really a question of, do you need IIS or not? And that's going to help you make the decision of, is this a web role or is this a worker role? So for example, our SMTP server, it's receiving traffic from the internet, but since I'm not using IIS, it's a worker role. Okay? So how do we receive traffic? We have something called an input endpoint. And an input endpoint means that stuff comes from the internet. It always comes through a load balancer. That's the model in Windows Azure today, is everything comes through a load balancer. And what you get if you have multiple endpoints is you get different ports on the same domain, or really on the same virtual IP address, so coming through the same load balancer. So what you cannot do today is in a single application serve up 3 different domains. You could if they all CNAME map to your thing, but you can't do it from different, you can't get different IP addresses routing traffic into your service. They are always load balanced. There's no way to do a sort of direct tunnel into a specific instance. You declare these in your service definition file, like pretty much everything you do in terms of modeling. In web roles, it's handled by IIS. In worker roles, it's handled by your code. And the trick to that is your code has to figure out what port to listen on. So while externally the load balancer is listening on port 80, say, internally they may give you port 20,000, and that's what you're supposed to connect to. In fact, because you run as a non-administrator, you can't actually probably listen on port 80 on the machine or some of the lower ports. So we tell you, hey, listen on this port, and that's where we're routing the traffic. So let's do a quick demo of input endpoints. So did you guys know yet that you can do this? I just double-clicked on my role in Visual Studio, and I got this new view that actually lets you do configuration settings, set up things like endpoints, local. Now there's actually a UI around this, so you don't need to go hack the XML if you don't want to. So you can still do it. You can still click on the service definition file and get the same thing. And so if we look here, we see that so far I haven't wired anything else up. So we just have a web page. So we have Mindchive web. I've needlessly said, I'm going to go ahead and delete it. I've needlessly said enable native code execution out of habit. That's now actually the default. So it's no longer that the default is this partial trust environment. You're full trust by default. And we have an input endpoint. And this happens automatically. Every time you create a web role, you'll see this. And you'll see HTTP in, protocol is HTTP, port is 80. And if you're doing HTTPS, you'd probably put port 443 here. So that's what we have. What does it take to add our SMTP server? We're going to add a role that already exists because I've written this one. It's a worker role project in this solution. And it's called Mindchive SMTP. And we got sort of a basic stub put in here for us by Visual Studio. It's missing one of my connection strings, so I'm going to go ahead and put that in. And then most importantly, now is the time for us to define that we're going to listen for TCP traffic on port 25. So we're going to say we have in endpoints, we have an input endpoint. The other one that you see there says internal endpoint. We're about to get to that when we talk about that, how to route traffic inside. So we have an input endpoint. The name is going to be, let's say, SMTP in. The port is going to be 25 because that's what SMTP listens on. And the protocol is TCP. Your choices are TCP, HTTP, or HTTPS. So basically everything that's not, let's make sure I got that right. Everything that's not HTTP and HTTPS, you're just going to say TCP. Okay? So that's all it took to wire it up from this side. Okay? But now we have code in the SMTP role that wants to open a TCP listener and listen on port 25. And as I said, we have to first find out what port it is that we're supposed to listen on, because we don't listen on port 25 internally. We listen to port random thing assigned to us. Port 25 is what the load balancer listens on. So let's take a look at the code for SMTP. And oh, actually, that's the wrong file. It's worker role.cs, which is what I want to figure out here. Okay, so I've already written a lot of the code here. So all the code that actually handles the TCP connection and the sockets and understanding SMTP, that's all here. What's not here is starting it all up. So here in onStart, I'm going to talk about onStart in a bit, but this is where I do my initialization. I want to call this start service method that's down here. And start service takes an IP endpoint. And this is where I need to find out where I'm supposed to be listening. So I'm going to talk to the role environment, and this is basically the way to communicate with the Windows Azure Fabric, so the Windows Azure environment that you're in. And I'm going to get, I'm going to take the current role instance, so me. I'm going to look at the instance endpoints. I'm going to look for one called SMTP_in, which is what we called it, and I'm going to get the IP endpoint. And that's it. That IP endpoint object, if you're not, it's a system.net IP endpoint, and it's got an address and a port. I mean, that's basically the whole thing. So I'm passing that into my start service. That's just using it to pass it to a TCP listener. So there's low level. I could have written C++ that opens a socket. I mean, it's sort of that level. Once you've declared up front what the port is and you've figured out where to listen, you can do what it is that you want. So let's give it a try and hope that I didn't forget a step. Oh, no, I would not. I would like to know what the build errors are. Data connection string. Oh, right. Remember when I said there was a missing configuration setting? I forgot to actually give it a value. csconfig. So let's just replicate these. And by the way, I always change the instance count of everything to 2. Do you know why you change it to 2? There's a blunt reason, and then there's the real reason. Let me give you the real reason first, which is that if you don't have 2, then as soon as one goes down, there's some lag before something else comes up. And so you don't have the availability that you have. The sort of more blunt reason is we don't provide an SLA unless you have 2. And it's really another way to say the first thing, which is that there's nothing we can do. Your app may crash, and we can't give you the SLA. In fact, we may do something like take a machine out to repair and whatever. And unless you have 2, so that when that goes down, there's still one up, we can't provide you the high availability that we'd like to. So you should really always set instant count to 2. If I were king of the world, the Visual Studio tools would automatically just say 2 when you start it off. There's some reasons why you may not want to always do that, but hopefully you understand the point. Okay, so nothing's changed here because we haven't touched the web thing. What has changed is we now have SMTP, and this comes to the most fun part of the demo. People recognize it. People know the tool PuTTY. So PuTTY is a telnet client, and we're gonna go old school here, and we're gonna telnet to port 25 and speak SMTP because it's a really simple thing. And the reason we're doing this is, first of all, it's actually kind of hard to send yourself mail to localhost, and so there's some tools to do it, but I didn't really feel like introducing one of those for just the purpose of this talk. And second of all, I think it underscores the point that we're just doing raw socket communication on TCP. So you can see, we'll pretend that we're at some domain called PDC.com. Let's see, what is it? Mail to, mail from. And I'm Steve Marks at Microsoft.com. And we're sending mail to, let's say, post@mindchive.com. Okay, here's the data from somebody to somebody else. Those really don't matter. We strip them out. Here's the subject of my email. Here's the body of my email. And if all goes well, this is now saving it to table storage. It says OK, which means things worked and we can quit. Okay, so just telnet, TCP, I mean, we're sort of, that's the level of this talk. Okay, so if we rerun our query in Azure Storage Explorer, we should see, and we do, this new message. Here's the body of my mail. Subject, here's the subject of my email. Okay, so now we can receive, imagine you doing this from an email client because it would make sort of more sense. But now we have a way you can take your notes in the session and send them to here, and they'll be archived forever. Okay, so that's input endpoint. So that's receiving traffic from the internet. So all of these go through the load balancer. All of these, I just listen on some port and I'm getting traffic that's routed to me. Let's have a brief aside about email because I brought it up. And I brought it up for a reason because I think that it's actually worth talking about. Spammers will use Windows Azure to send lots of mail. It's a prediction, but it's a sure bet, okay? It's because it's a scalable platform. I can go spin something up, and then when all the servers start going, we're not going to listen to this IP address, I can change it by just redeploying. That means that the IP ranges in Windows Azure are somewhat likely to get blacklisted, and we've seen this happen before to other cloud platforms. That means you cannot rely on sending mail from within Windows Azure. You can today, because it hasn't happened yet. We haven't gotten sort of beat up by spammers. But don't plan on an architecture like that. If you're going to send mail, do it through a relay, like authSMTP or SendGrid or one of these guys who are trusted, who fight spam on their side and therefore don't get blacklisted by the various spam lists. Okay, so if you're going to send mail, you can do that. Receiving email is fine, because the way receiving email works is somebody just looks up the MX record, then goes and talks to your server. They don't care if you're a spammer, because the problem with spammers isn't that they're receiving too much mail. So just this is the point about email. I think it's a great idea to actually run to listen to SMTP traffic from in Windows Azure, but sending mail, I would be careful, and I would use a third-party relay service. Okay, so let's talk about searching. So now I've uploaded all these things, and so far all we can do is look in Azure Storage Explorer and see them. I'd like to build search on top of this. There's a search engine called Lucene, which we mentioned before. It's a very popular search API. I would really say that Lucene is sort of the combination of the API and the way the data is stored on disk. That's sort of the brilliance of Lucene. Then there are different implementations in different languages. So it's not like a library where everybody re-implements or implements a wrapper. Everyone's actually implementing again, usually based on the original implementation, which is in Java. And Lucene.net is a pretty good port, as far as I can tell, of the original Java implementation. So it's very fast at searching. Does a great job, knows how to build indexes. I'd like to use that in our service. There are a couple things about indexing the data, right? So I actually have to, first of all, when I start up, I have to catch up. There's a bunch of stuff that we've already done it. We've inserted two different things into table storage, and our index isn't going to have those yet. So when we fire up Lucene, the first thing we have to do is go get all the old stuff, build up an index. That index is going to be in RAM and on disk. And then continually update it. So as new things come in, I'm gonna keep updating. I'm gonna rev sort of that index each time as I go. And then I'm gonna actually serve searches. And here is a place where that nice and pretty web role with a queue and then a worker role picture isn't so great. Because what I'd like to do, the user is waiting. The user's pressed a button, they want the search results. What they don't want to do is wait for me to sort of queue something up, somebody to pick it up later, go search, and then put the result somewhere else. I want to do direct synchronous communication. So I want to grab a Lucene server, ask for the answer, and come back. We're going to run more than one Lucene server, by the way. So they're all going to be maintaining their index. When it comes time to ask the question, we can just sort of load balance. We'll just ask somebody and get the answer back. And so we'll gain a lot of performance out of that kind of model. And we're going to use WCF for the communication. I could have used something else, and in fact, you'll see I'm using TCP-based WCF just to make the point that it's not that we've done some .NET thing here. It's that once you have an IP endpoint, you can just talk. Okay. So I'm doing something that I think I'm just going to call out here because I think it's interesting, and it may surprise you otherwise when we take a look at the code. I'm doing asynchronous work and I'm not using a queue. And the asynchronous work that I'm doing is updating the index. So every time I insert something, all those Lucene servers have to go update their index. Normally you'd use a queue for this sort of thing. But queues have the nice property, but undesirable in this case, of delivering each message to one receiver, to one consumer, to one worker. So if I sort of naively just put up a Lucene server in a front end and then I enqueued everything and the Lucene just dequeued it and then updated the index, I'd get this sort of weird thing where each server had only sort of a part of the view. There are a number of things I could do. I could set up one queue per worker, but now I have to be really careful about when new workers come online, and I have to worry about sort of the timing, the bugs that may creep in of sort of somebody just disappeared and their queue is still there, and now somebody else came up and I'm not sure if they saw that message, stuff like that. So you could do that. You could do synchronous communication. So you could just say, well, when it's time to update the index, I go reach out to everybody at once and I tell them all to do it, and I don't return until they've all said yes. And so if you do it synchronously, then you know that they've all done the update. But you have to wait. Now you have to wait for whoever takes the longest to do it. I've done something different, which is I've sort of rebuilt a queue. I've built a table where I insert all these things, and each index server is just saying, hey, is there anything in the table I haven't seen before? And if there is, it goes and adds it to the index. Now, this will keep growing, because I don't know when I can delete the old ones. And in fact, I'm using the same process at startup. It just churns over that whole thing, builds up the index again. So if you're going to do there's one thing that I really want to call out, and the reason I have to call it out is because in my code, I didn't take care of this problem. Okay, so I didn't do this, but you need to, which is make sure that you order these things. I'm using datetime.utcnow.ticks, so I'm just looking at what the current, hey, my watch says that it's 2:30, and I put that timestamp on there. That's not good enough, because there may be clock drift. It's good enough for my demo here, because I'm never going to type in things fast enough that they'll ever sort of show up out of order. But if anything's ever out of order here, then you have a worker who said, well, I processed message number 7. Now, next time I only want 8 and above. But really, the new one you inserted is 6 or something, and you never get it. So if you're going to do something like this, consider doing something like locking. We now have a lease, the ability to lease blobs. Consider doing some locking mechanism to make sure that you don't sort of insert things in the wrong order. Okay, so we have to do 2 things really here in the search thing. One is we have to figure out how to build that index and keep it going. Keeping it going, it turns out not that complicated. I just described how it works. Starting the index, there's one thing to watch out for, which is what I don't want to do is spin up a worker. It's busy indexing all the old stuff, and while it's doing that, I ask it to fulfill some search. And it says, well, I don't have any results, because it hasn't gotten there yet. It just hasn't added to the index. So I want to wait until this thing is done indexing. We have this new thing called the role instance lifecycle. Used to be very simple. You used to just get a start, and you just sort of never returned. There's now an on-start, which is an initialization routine. There's run, which is where you do all your work, and then there's on-stop, which gives you a chance to do graceful shutdown. As always, never count on getting to do graceful shutdown. Make sure your app behaves properly if you just pull the plug. But this is your chance, if you can do something to sort of save where you are or something. These interact with sort of the way that communication works. So in initialization, your role is in the busy state. So if you ever deployed something in Windows Azure and you watched it say like allocated, and then you hit run and it said initializing, and then sometimes it said busy and you didn't know what that meant and whatever. Busy means you're out of rotation. That's basically what it means. It means that if you're a web role and you're busy, the load balancer is not routing traffic to you. You get taken out, the load balancer takes out that IP address as soon as you're in the busy state. If you're internal and people are talking to you, you get taken out of sort of the enumeration API. So the same sort of thing happens where you're kind of invisible while you're in the busy state. You can set yourself in the busy state later if you want. If something goes wrong and you need a breather and you need everybody to leave you alone for a while, you can set your state to busy and everybody will stop talking to you. Wish real life worked that well. So OnStart is brilliant because it lets you do all this initialization before you're expected to be doing live things, right? Run is where you do everything else. OnStop, as I said, you get graceful shutdown, but don't count on it. So how are we going to actually do the internal communication? So now that we figured out how to build our index, how to keep it going, how are we going to serve those search requests? And we basically use an API. It looks very similar to what we did in that first one. There's an API that says, what port should I listen on? That's pretty much identical, whether it's a port that's coming from the outside or it's just coming from internal traffic from other role instances. Then there's an API on the side of the client to find out who to talk to. So there's the web front end, and it has to know who's the search guy and what addresses he had. And specifically, where is he now? Because last time I talked to him, he may have been at a different address because he may have now been upgraded or he may have moved or something. And there may be many of them. So how do I find out all of them, find out who it is that I'm supposed to talk to? So there's basically an API. It looks fairly similar, but it's on both sides of this. So let's take a look at onStart and input endpoints. I think we're actually going to do them in the other order. So let me stop debugging, and let's do what we did before. Let's add a new role. I'm going to work a role in this project. The only one left that we haven't done yet is search. So I had search. I'm going to do the same thing. I'm going to bump it up to 2. I'm going to set the settings. I'm going to make sure here that I have the same settings. OK, and now I need an endpoint. And the endpoint is this time an internal endpoint. So remember, there are the two options, input endpoint and internal endpoint. They're hard to say, but their meaning is hopefully clear. That input endpoint is input into the system. Internal is traffic within the system. So internal endpoint is what we need here. And there's something missing this time. So we're going to give it a name just like we did before. I'm going to call it search in because I'm very creative. There's a protocol just like there was before. We're going to use TCP in this case. What's missing here is port because it doesn't matter. What matters is that both sides know what the address and the port is. We figure it out at runtime, and it depends on how many you've asked for and what else is happening and whatever, and we just assign a port. They're actually fairly predictable. If you go look at them, you'll see that they generally follow the sort of one after the other pattern. But at an abstraction layer, the point is you don't need to know. And in fact, you should avoid taking a dependency on expecting some behavior from this. So you'll always use the API to find out on the server side, what port you're listening on, and on the client, what port to talk to and the IP address to talk to. OK, so we do that. Let's go over to that role, the search role. Go to our worker role where you can see that I've sort of pulled in all the Lucene stuff. I have all the code here. I have the code that does stuff, but you'll see there's some big blanks. Like the run method is completely blank, and there's some other things that are kind of missing. And in here we're going to do a couple things, but since we just did the endpoint, let's do the starting the search service. So we haven't dealt with sort of the index yet, but I'll fill that code in a minute. But what we want to do is call OK. I apologize. We should do one more thing before we do that, because otherwise we won't have what we need. So, all right, coming back to CSDEF, right, where we're defining what this role is. We defined the internal endpoint that we need to listen to. There's one more thing that we need, which is we need the local disk in this one. Okay, so I'm going to go ahead and do that now, because just the line of code I was about to write, I realized I can't do until we do this. So let's say here that there is a local storage node. The name of it is going to be, say, search index. And we're going to make the size, let's make it 1,500 megabytes. Okay? So that's where we're going to start. The reason I'm choosing 1,500 megabytes is because what I know is that the way that I've built the Lucene stuff is that it's using a RAM directory, which it goes on top of local storage. So everything's going to be written there, but everything also has to fit in memory. And so I'm going to go ahead and say 1,500, which should be safe on a sort of normal small VM size to give me the room that I need. OK, so now that we've done that, let's go back and do that line of code. So what we want to do is we want to call a couple things. We want to create our writer. So we have a writer object. We're going to create it. And the reason we haven't filled this in yet is because we don't know the path. And that's why we needed to go do that. So we're going to just ask the role environment for get local resource. We called it search index. And we're going to get the root path from it. So that's the API. This hasn't changed, by the way. If you've used local storage before, that API is pretty much the same. I think the word role environment is sort of different because we've revved the API a little bit. But it's that. And so that sort of sets up our writer. we're going to do some code here that's going to update everything, sort of get ready, and I'm going to fill that in a second. But what I wanted to do next is sort of start the service. And so I have this start service method, and just like before, we had this, it takes an IP endpoint. And so I've written all the code. It knows how to sort of set up the WCF connection or whatever. But what it needs is the endpoint to listen on. And so we're going to do the exact same thing that we did before, which is take the current role instance, get the instance endpoints, find the one called search in, and get the IP endpoint from it. So the reason I wanted to write that line and sort of take you through it is because it's the same as the other one. And so whether it's an input endpoint or an internal endpoint, if you're on the listening side, you do the same thing. You call the same API, and it works the same way. OK, so let's go fill in this update code. So now that we've sort of started our search index and we have a writer for it, I wrote some code that does the update. The reason I wanted to sort of stop here and show this a little bit is because it has to do with that pattern that I was talking about asynchronous, using a table. And so what I've done is I've written a method called update. Let's find that, update index. And this does the look at the table, see what's there, put it in the index. And specifically, the thing I wanted to call out is that I do it in a loop. And you see this line that says, while new stuff. And what I'm doing here is basically query tables, see if there's some stuff that I don't have in my index yet, add it to my index. If there was something there, do it again, and do it again and again until I get to some point where I'm fully caught up. Okay? And this is to avoid some of the sort of race-like conditions, where I grabbed everything and I said, great, and I went to go update my search index, and I'm actually way behind by the time I get done. So this gets us to the point where at some point, we're caught up, right? We're always going to be falling behind and always catching up again because it's asynchronous, but this gets us to sort of a good starting point. And this uses something here. This uses this last row key. And actually, I suppose the important part is where, sorry, not there, here, where we compare the row key to the last row key. So that's basically how we're keeping track of which things are new. Okay? And for now, that's about as much as I'm going to say about that method of sort of keeping track. We're going to come back to why that last row key is significant and how we're keeping track of it. So here, I'm just going to write a couple lines of code. One, we have a writer already. We're going to do a call to get last row key, which actually returns the row key. So we're going to set last row key to that. Again, leaving it intentionally sort of out there of why we're doing that and the way that we're doing it. We're going to call update index once, and that, as you know, is going to loop until we're basically caught up. And then we're ready to call start service and return. This was all in on start, which means during all this time, we got it for free. This was when the door is closed, there's do not disturb sign, and nobody's talking to us. So we get to just catch up, figure out the index, get our WCF endpoint started, and then we return. A little while later, we'll get called in run. So the on start and then run. Okay? And in run, we have an incredibly difficult loop to write here, which is this. So the WCF endpoint is listening, so as stuff comes in, it's going to respond. And then in run, just forever, we're just going to be updating the index. So we call update index. It may loop itself until it's caught up, and then it's going to return, and we just say, hey, do it again. Update index, by the way, does have a built-in sleep in it. So at the end, once it's caught up, it does wait a second before. So if there was nothing to do one time, it'll wait before it does it again. That's to sort of avoid, spinning in a tight loop, which will consume a lot of CPU cycles. So I'll compete with myself because I have a WCF listener there. And it also consumes a lot of transactions and storage. And if you've been following sort of the pricing announcements and things, we charge by transactions. It's like a penny for 10,000 transactions. So it adds up slowly, but it adds up. If you find yourself in a loop that was doing something every couple milliseconds instead of every second, that's a significant difference. And so that's why I have that logic in there. Okay, so I'm nervous now. This is probably this is the F5 of the talk. This is the one where it's like anything could happen because he just did like 4 or 5 different things, and what if he forgot one step, right? So I'm a little bit nervous. I hope you guys are too. The tension is good. This guy's got it. The guy in the front row doing just the shaking hand for me. I appreciate it. Some solidarity, some dev solidarity. So what did we do while we're starting up? So just let's recap slightly, which is that we created this role, we gave it local storage, and we gave it an internal endpoint. Oh, I know what we forgot to do. This is why we recap. It helps me to remember what we did. So what did we do? We listened on the right port. What did we not do? We didn't hook up anybody to talk to us. Okay? So hopefully this will actually run. It's probably actually working. There's probably a WCF endpoint we could talk to. But this search box doesn't actually use it yet. So let's go back and edit. So in the web role, we'll go over, there's a search here. Aha. See, we would have found it in a second if I just tried to do it. I left myself a little hint. OK, so this is not implemented yet. What we have to do is we're going to use that in endpoint. So we're going to use an API to get the IP address that we want. And we're going to use a class that I've created. I'm just going to throw this up on the screen for a second here just so that you can see that it exists. I have this search client, and this is just, if you did WCF and ran the tool, this SVC util, and sort of spit out some code, it looks a lot like this. I actually wrote it by hand because I'm weird like that, but that's all it is. So it's a proxy class to do this. So here we're just going to do var proxy equals new search service, search client. What's that? I don't like the goo. That's right. I don't like the goo that comes with the service util. Especially on screen when you show it on the big screen. I like it to be kind of clean. So you're right. That is the reason. OK, so I'm going to do role environment. Now remember, all these times we've been doing this current role instance because we're looking for stuff about us. That's not what we're looking for this time. So we're looking for roles. And we're going to look for the role that we've called Mindchive search. Let's actually, you know what? Because we have to load balance. Let's do it this way. So here we got the instances. Okay, ignore this line for a second. So we got the instances. We have to choose which one to talk to. And I want to load balance. There's no load balancing on the internal endpoints. External ones always load balanced with an actual load balancer. Internal endpoints, you can talk to whoever you want to. So you can build things like distributed memory caches, and we've showed memcached working in this way here earlier in the conference. By talking to specifically one or the other, but a lot of the times you will want a load balance, and I'm gonna write some really fancy load balancing code here, which is so we're gonna get one instance, and we're gonna take instances and index into it new random dot next, and we need a cap. We need how many of these there are, what the max value is, and so we're gonna say instances dot what do I want? Shouldn't there be a count? What's that? Somebody knew the answer? It's because I did this, actually. It was a trick question. You couldn't have really answered that. I was just testing you. OK, so that gives us one specific instance that we're going to talk to, and we chose it at random, which is actually a pretty good way to do load balancing. Now, you could do something else. You could do round robin intentionally or something. But remember, there are lots of consumers of this service also. I have a bunch of web roles. They're all talking to a bunch of searchers. Random is actually a really reasonable thing to do here. So now we need to pass in the endpoint. And so we're going to pass in the we're going to take from that instance that we have, we're going to find the search in endpoint, because that's what we called it, and we're going to get the IP endpoint. So that's hopefully starting to look familiar, that bit of it. What's different is instead of taking the current role instance and enumerating your stuff, we're going to roles, we're looking for the named role, we're getting all the instances of that role. All the non-busy ones, that's correct. That's a good question. So what about the busy ones? And they do not show up in this API. And so that's important. So that means that those searchers do have the time to catch up on the index before we start routing traffic to them. OK, and then we're going to return our view with, well, let's capture it. So we're going to take call from the proxy search, and we're going to pass in the query string that we got. We're then going to close it because we're trying to be well-behaved people, although I didn't use a using pattern, so exceptions are going to eat some of these proxies. You would all do better, though, I assume. And then we're going to return a strongly typed view that takes those results. So the results are just a list of those chives, as we're calling them, so it's a list of those table things. The view takes those things. OK. Now we're going to recap again because we're going to find out what else I forgot, right? So we added the internal endpoint. We set up on the search side, which is sort of the server of this, we launched the WCF service with the right endpoint. On the client side, the consumer who's doing the search, we wired up the proxy to talk to the right address by using our friend random to do load balancing. We put in local storage that we're using on the search side to sort of build up the index locally. And as I said, it's also in memory. And if all works, we should now be able to do something fun like search for that email that I sent by typing it into Telnet. And it has the word email in it, doesn't it? Yes, it does. OK. So we should, if we did everything right, we should be able to search for email and see our email come up. And then everyone can stop being nervous. I don't know. It's a little slower than I'd like. We do actually have to, there is the possibility that there's time being taken, that we are in the busy state. And there it is. All right. OK. So it worked. So we hooked up search, did internal endpoint. Thank you. So you can always get everybody to applause if you make it suspenseful like that. When you have low confidence that I can actually make the demo work, then when it works, it's great. OK, so let's talk about getting more RAM, because I made that big point about making sure that I made the size of my storage just small enough, because I knew that I'm using the RAM and I don't have that much space. So that RAM directory in Lucene.net, in Lucene in general, puts everything in memory. Then it also stores them on the disk, but the point is all the searches and whatever are served directly from RAM, which is a good way to get some performance. If we have lots of data, we're going to need lots of RAM. You can now choose among 4 different VM sizes in Windows Azure. So you can choose whether you want a small, a medium, a large, or an extra large instance. And they're all basically multiples of each other. You get 1 core with small, you get 2 with medium, you get 4 with large, you get 8 with extra large. You get 2 gigs of RAM with small, you get 4 gigs of RAM with medium, et cetera. So they're multiples. And there's a good reason, because we take a machine, we carve it up into 8. It's an 8-core machine. We carve it into 8 instances, and we give you 1. And if you want more, you just have multiples. It's just how many cores do you want, and we just assign everything with the cores. So you get proportional RAM and proportional everything. It's a really easy edit to make this change, and we're going to do it in a second, but you just VM size equals extra large. I mean, that's it. And there's the schema tells you what the different choices are, and that's all you have to do. OK, what about the index? So now we're going to get back to sort of what I left hanging on sort of that get last row key. Remember, we're sort of keeping track of the last one that we saw, and I didn't show you the code for where that get last row key stuff was, and I'll show it to you now, because Lucene.net writes files to the local file system. So it keeps everything in RAM, but it also writes to the disk. It would be a shame if when I upgraded my code or did something else, I had to reconstruct the index every time from scratch. So what I'd like is for that stuff on the local disk to stay around. And I want to pause here and say you would never get the guarantee that this will happen. So this is like a disk that's attached to your virtual machine on that server. And so it's not replicated, it's not fault tolerant. It doesn't, when you scale up or down or whatever, the new ones, they don't have that disk anymore. I mean, it's very local. But what you can do now is you can ask us to keep it around when you do something like restart the role. And so, for example, you might do that when you're deploying an upgrade. So while you're upgrading your code, it's actually possible for us to keep that local storage around. Only use this as an optimization, which is what we're going to do here. I think we're actually using this one as a best practice here, which is that you don't get the guarantee that your stuff will be there, but if you wake up and you're a new role instance and you look around and there's a whole search index already, use it. And so that's why we're actually keeping track of that last row key, and we're putting it on disk. And we're putting it on disk so that when we wake up the next time, we know where we were. So consider writing state in onStop. onStop is where you get this opportunity for some graceful shutdown. If there you can do something like write to disk, hey, I was on record number 35, so that when you wake back up, you know exactly where you were. This is a great place to do it, is to do that in onStop. OK, so let's just make those changes. These ones are really easy and really quick, but I just want to show you the exact syntax in case it saves you some time sometime in the future. So let's close that. let's just hop over to our definition file. And here for search, we're just going to say VM size equals extra large. So that's it. So just on the worker role node itself, you just say that's the VM size. Now, now we can bump this up, by the way. Now we can take our local storage and we can say, well, actually, we're going to have something like 16 gigs of RAM. Let's be safe and say 15, so 15,000 megabytes. And that should, and then now we're going to be using that much RAM, that much disk. So we're going to do that, and then we're going to do clean on roll recycle equals false. So don't be confused by this. It's a little clean on roll recycle means we'll delete it. So when you, and that's the default. And so when you don't want that to happen, you set it to false. So the default for this thing is true. You set it to false. I know it's a little strange because we're introducing a new thing and it defaults to true, and it's a little bit confusing. Don't be, just read the clean on roll recycle and then you'll remember, oh right, so that I want false. So make sure you do the right thing there. And then I'm gonna quickly jump back to this code and just show you where we're using this, where we're taking advantage of this. And here in the worker role, we have this code. So remember here we did last row key equals get last row key, and where it gets it from is here. It gets it from the disk. So it actually looks in that directory. It looks for a file called, I believe, lrk.txt, last row key.txt. That tells it where to pick up. So basically that's always in sync with the search index. So in our updating code, in update index, we're doing update last row key every time. So after we read something, we write that to disk. And update last row key is just writing to the same location on disk. So basically, every time we update the index, that gets saved on the disk. We also save a little marker on the disk that says, hey, the last one we processed was this. So then when we wake back up after an upgrade or something like that, we know where we are. We go, oh, well, I've got everything before that. All I have to do is just read it from the disk, and I'm good. And Lucene knows how to do this already. When I instantiate it, when there's a directory that's already there, it can just start using it again. Right? So that's VM size and keeping your local storage around. So how do we take advantage of that local storage and actually some other things is using in-place upgrade. And in-place upgrade is fairly new. It's like it's on the, what is it? It's a couple months now, maybe 2 months ago that we rolled that out. Roll being a good word here because it's a rolling upgrade. And so this is everything's running. You have different upgrade domains. We take one down, bring up new bits. We take the next one down, bring up new bits, next one, et cetera. So every time you do an upgrade, you do it in place. You don't spin up a whole other thing and swap, which is our other option, the swap, where you bring up a staging environment and then take the whole thing over. You can do this one in place without spinning up extra instances. And it has a couple nice properties. One is that you can specify which roles to upgrade. So if I changed my web UI, why would I? Because it's beautiful. But if I did, and I didn't want to mess up my search index, I could say just update the web role. And then the search wouldn't have to forget that I've saved some state on disk and I can sort of reinstantiate things. It would just never get touched. The search thing would keep running the entire time. So being able to specify just which roles you want to upgrade is a big advantage of using in-place upgrade. It also keeps local storage intact if you've said don't clean it. So even if I upgrade my search, my search service, as long as I do it with an in-place upgrade, the VM will sort of be torn down. It'll come back up, but the local disk will be just how it was. And so now I can sort of pick up where I left off. So I'll lose all that stuff that was in memory. So I'll have to load it from the disk again. But it hasn't been wiped out. If I did something like a swap, I wouldn't get this because I'd be spinning up a totally different thing and then putting it in place. And so it obviously wouldn't have any of the local storage. So this is great for stateful roles, of which a search service like this, where it's maintaining an index locally, is, right? It is a stateful role. And so using the in-place upgrade is great for that. Okay, so in summary, this is what we built, right? We had IS serving ASP.NET MVC. We had SMTP on port 25, which I proved to you by using Telnet. We have search in the back that's serving up via a WCF service. Search results is using local storage that's kept around to keep that search index. It's using a big VM to keep as much of that in memory as possible. And they're all accessing storage using tables. We didn't really talk about that, but there I was just doing some sort of standard table entity, any transactions. So any instance can talk to each other. This is the news, right? Any instance can talk to any other instance. You don't need IS to listen to traffic. Use that role instance lifecycle to do things like say, I'm busy, don't talk to me, and then to do graceful shutdown at the end. You can choose among those different VM sizes, so figure out what's optimal for your code. It really varies whether it's better to have sort of 2 single cores or 1 double core. And so you'll have to decide that in your application and do some benchmarks and figure that out. And in-place upgrades give you some great options, particularly for stateful roles, like the search role that we built. If you would like a free flip camera, and we're not out of them yet, which, does anyone know? Are we all out of these by now? Maybe not. OK, then you guys, I know it's no, here's a free laptop, but we have these cool things, and they're actually branded with the Windows Azure logo, so actually they're kind of nice to have. And it's a little flip camera. What you have to do, though, is on your way out of here is pick up a little card. So someone should be near the door as you're leaving, and you should be able to pick up one of these cards that says you were at a session, because you have to sort of prove that, and that gives you the mouse. If you then go do a hands-on lab also. The mice are gone? Are the cameras gone, though? The cameras are not gone. Oh, OK, wow. So the card gives you nothing except the right to do a hands-on lab and then get a flip camera. So you still need it. You still need it to sort of prove that you've been to a session, because we only like the people who've been to one of our sessions. So we like all of you. And please do fill out feedback forms. I appreciate feedback forms a lot. As I said, I do a lot of speaking, and for me, this is the way that I learn how I'm doing. So please do fill out the feedback forms. And you can go to Channel 9 later, and there'll be all sorts of stuff. If you have questions, dev.windowsazure.com is our developer-facing portal. That's my stuff. That's my blog and my Twitter account. The next best thing to go to if you're interested in really advanced patterns and practices is Brad's talk, which is at 8:30 a.m. tomorrow. So I know you have to get up early and go to it, but it's going to be awesome. It's sort of best practices, tips and tricks from the storage guru. And so it's really good to go to. Thank you so much for your attention, and I'll hang around for questions. Thanks.